Okay, so next up, we're going to talk about basalt fibers. Basalt fibers are similar to fiberglass. However, they are lighter and stronger. Their properties pretty much all the way around are better than fiberglass: insulation, structural, etc. And so that's why I wanted to bring them on. I see applications to this in construction, across the federal government, across Navy, Air Force, aerospace. I don't know that there is any industry really that they wouldn't touch. Medical applications, etc. So with that, I am going to turn this over to Nick. Nick, are you going to be able to run your presentation? Because I have not been able to access it.
Okay, I'm hoping so. I'm kind of new to meetings. I use Zoom a lot, but will we be able to share a screen from my laptop? So,
yes, if you go up to you'll either have a menu at the bottom or at the top with an up arrow that says share.
Mine says more. Let's see, record, meeting info, video effects, share. Here we go. Okay, I'd like to record this computer. Do we want to record it?
I'm already recording it, so.
Okay. Center mode, window. Okay, content. Okay, it's share content. Nothing available.
Okay, so when you go to share, you're going to have a lot of options.
Yeah.
You're going to want to select your window and then pick whichever window it is that you want.
Yeah, and clicking on them, but nothing's happening. Add background. No.
I sent you a link to my Google Drive, my G Drive. Can you drop the presentation in there and I can run it?
What I've got is it's actually online here. Yeah, let me get back in my email. You just sent that?
Yeah.
Okay.
But if you want to start discussing, or Brian, if you want to step in and start talking while we're doing this.
Okay. Is Brian there?
He is.
I'm
so
sorry.
He was.
I'm here.
Sorry,
I am here. Yeah.
Okay. Let me just choose this file, send it, and I get that. Okay, I can start anyhow. Well, while that's coming, Eugene. Thank you, ladies and gentlemen. I am Nick Sancarelli, Smarter Building Systems. I live up in Newport, Rhode Island. I was in construction for over 40 years. Owned all my own businesses of concrete and masonry, mostly in carpentry, and worked all over the world doing construction. And I was building a dome with a friend of mine and happened to come across this basalt volcanic rock. At the time, it was rebar for making a dome. And I said, well, that's interesting. And I met a Russian woman that brought it to the United States. Basically, we invented basalt back in the 50s. We dropped it and went with asbestos of all things. And the Russians picked it up and perfected it and kept it a military secret for a few decades, because of its RF stealth properties. The more I got involved with it, the more I found out that it also has fibers for the composites industry. And we take rocks and melt them just like you would steel or in fiberglass, or make fiberglass or carbon fiber, and pultrude that through the platinum rhodium bushings that make filaments of rock into fibers. These have a lot of extraordinary properties. They are 2 to 3 times stronger than steel in tension and 70% lighter but never corrode. Basalt is UV immune, a 10 times better electrical insulator than fiberglass. It doesn't harbor bacterial microbial growth, and it handles hundreds of degrees hotter and or colder, and even extreme cold for cryogenic and liquid hydrogen storage opportunities. We make all kinds of sporting goods, prosthetics. Wilson puts it in tennis rackets and Rosinol in skis, surfboards, skateboards, all kinds of pipe, high temperature jacketing, and now we're building boat hulls and automotive parts and doing thermoset and thermoplastics with the basalt fibers. So I'm trying to pull up this window here. The other thing, because I was a small company, I was kind of found niche market opportunities with people that I discovered who have unique properties for high temperature coatings and ballistics and things of that nature. And a couple of my associates make things like siloxanes and or nanoceramics that are coating nose cones on 13 SpaceX flights. And so what we do is combine those with the basalt for high temperature applications and or extreme cold temperature applications with thermal capacity. And some of those coatings include an aerogel. An aerogel is basically tiny little silica beads that are the most insulating thing on the planet next to a vacuum. We've incorporated those into fabrics now, both the inorganic and organic versions. And the inorganic version, I can show you when we get the presentation open, an E94 vertical burn test, and then no, it literally doesn't burn. Wrap those around electric vehicle batteries for insulation and stopping thermal runaway. The aerogel is 2 millimeters thick, and yet it's got the insulative quality of over an inch of like polyiso foam. So the combination, what I've found is combining aerogel sheet fabrics with the basalt is extraordinarily capabilities that if you have a lot of room, you could use thick insulation that burns and smells and whatever and gives off toxins. But this combination is for where you don't have a lot of room, but you need the ultimate and thermal capacity and insulation, as well as durability and impact resistance that you get from a basalt fiber compared to carbon or glass or Kevlar. Kevlar is good for bullets and projectile, but basalt is actually better for blast and wider impact. So we've done things like making wraps for weapons that they can't handle because they get too hot. And so now the combination of this little thin jacketing allows people to hold on to that. We have a video of a guy picking up a piece of dry ice with his bare hand with a 2 millimeter flexible foam of aerogel. So the properties of these for things like we made a ice chest for a fishing boat and used the regular 3 inches of foam and 2 layers of fiberglass that you would use in an ice chest, and did a similar box with the aerogel, 2 millimeters thick. So we got almost double the storage capacity, and he filled them both up with the same amount of ice. And the regular ice chest in the California sun was in a day and a half was pretty much melted, and our ice chest with a lot more storage capacity went 4.5 days and still had ice in it in 39 degrees Fahrenheit. So that's I'm kind of doing a quick synopsis of this, and I can't get my PowerPoint to sort of work.
I got the email you sent me, so I'm gonna be opening it up here shortly. You can go ahead and keep chatting.
Okay. So the other thing we did was make a latex rubber version of the aerogel, for which we're doing dive suits and wetsuits and special forces jacketing and boot liners and hats and gloves, because it's so thin and flexible. And if you get aerogel fabrics wet, they don't lose capacity like a fiberglass or down or wool insulation. And also, if you compress them, they don't lose the thermal capacity. So you could make sleeping bags or jacketing or anything for extreme cold or temperatures. And the other thing we found out was we sent a drone up with a heat signature camera and had a guy hold a blanket over half of his body, and you could not see his thermal signature underneath underneath our aerogel blanket. So the combination, I mean, obviously, basalt being its impact tolerant, completely recyclable, renewable, and we can mix it with bioresins now that are completely recyclable and have at end of life, you grind it up and make something else out of it. And so it's actually truly a recyclable fiber. We can commingle it with hemp or jute or canaf or whatever other natural fibers as well, if wanted. We we've done lots of testing and show that we make like 5 skiffs for the Keys fishing boats in the shallows, and they're all coming back saying how much they love how it wets and how it takes impact. They run up against the rocks or on shoals, and it doesn't puncture through like a normal fiberglass hull would. So the Basalt has great flexural modulus is about 25% higher than fiberglass. So it's not as stiff as carbon and not as soft as fiberglass. And we make rebars still out of it and meshes and things for structural and seismic applications. Or like I said, our rebar is 2 to 3 times stronger than steel. It's 70% lighter and it never corrodes. Sorry about the presentation. This is a piece of the Basalt fiber fabric and a piece of the high temperature aerogel on the back of it. This aerogel was tested and certified by NASA, 2 millimeters thick, as the best that they've ever tested. And this is what they're using for thermal insulation and battery containment, insulation and thermal runaway. This is a piece of the stretchable aerogel fabric that we put in clothing, line it in gloves and hats and boots and whatnot. There's a perforated and non-perforated versions of this. Stretchy, flexible. You could drape it over military equipment, anything, and help hide thermal signature while giving you the best insulation and the lightest possible. And this stuff weighs literally nothing, but like I said, 2 millimeters is worth over 1 inch of regular polyiso foam. These are rebars that we make 70% lighter, 2 to 3 times stronger than steel. All different sizes, diameters. It comes in coils, 100 meters, 328 feet. I can pick up a whole coil with one hand. We make press boards and insulated fireproofing, compressed boards in a phenolic resin, and all kinds of meshes and things that you normally put in concrete and can also be put into composite applications. We have whole lines of sleeves and tapes and prosthetics being made exclusively but with the Basalt fiber fabrics. Does anyone have any questions?
Nick, this is Brian. I have a question.
Yes.
Could you give just a very rough rundown on a recommendation to insulate and protect a high voltage power transformer for a power company who does not want people shooting bullets into it, or the forest fire burning it, or saltwater spray damaging your electrical stuff? Can you walk us through, like, how would you approach upgrading?
Well, it would probably consist of an assembly if you want thermal insulation as well as ballistics or penetration. So you would probably like I did with the Basalt aerogel combination. And, you would have an interior fireproofing thermal wrap with multiple layers of fabrics, and it could be. We have biaxials or triaxials, which means they're crossed on top of one another and laid up for very thick, durable, and protective. And they'd probably be epoxied or some kind of a urethane or polyvinyl ester or something of that kind of resin combined with them. I have fireproof epoxies. We actually have a Bizay-free epoxy, which is a bisphenol A, which is completely non-toxic. We've done multiple layers of basalt and shot 50 cal into it, and from a distance, and actually regular even 30 caliber will stick into it. The 50 cal went through, but it self-healed itself after it went through. But we can put multiple layers of that and build up a very high tolerance in whatever you're trying to develop, depending on thick it is and or what your properties are that you're trying to achieve.
Hello, my name's Chris
Go ahead.
Hakimian. Sorry, I didn't raise my hand. Was just wondering, do you see applications for this material in hypersonic vehicles? Over.
Well, like I said, I work with my guy in Montana who makes coatings for hypersonic vehicles. And the aerogel is certainly something that would be used for something like that. Yes. We did an interesting study recently with liquid hydrogen tanks, and the basalt outperformed carbon fiber. I think people didn't realize because they look at fibers and they take their ambient temperature properties and assume that that's what's going to be at hundreds of degrees below zero, but in actuality the properties change and the thermal efficient expansion coefficients change, and the basalt actually outperformed carbon fiber at extreme low temperatures.
Outstanding.
So
It actually is
go ahead.
and actually, no, I'm just going to say also in nuclear, when exposed to high levels of gamma radiation, all other fibers lose significant mechanical strength. Basalt increased by 5%.
Nick, Bill Brunner from New Frontier Aerospace, and we're looking at building hypersonic vehicles.
Okay.
So we have settled on 3D printing as our manufacturing process because there's some fairly exotic shapes that we need for our tanks that we just can't do with traditional metal fabrication or carbon layup. Carbon fiber layup would work, but it would be very expensive. How can you sort of compare the manufacturing processes of your basalt tanks versus versus additive? Go ahead.
Yeah, exactly the same. We make filaments of rovings that, just like you'd have 5K carbon or whatever. We make filaments of various microns and TEX, they call it, or the yield is the number of grams per 1,000 meters. And we can certainly do the same, but at 4 to 5 times less expensive than carbon and non-conductive. Sometimes people want to make things conductive and they add fibers, filaments to do that, but you could spray graphites or whatever if you wanted to make the basalt conductive, but right now it's completely non-conductive. And you could filament wind it, RTM, vacuum bag it, however you're doing your carbon.
Okay, follow-on question. What's the density with respect to carbon? Is it go ahead.
It's a heavier density. The carbon is about one of the lightest that there is. But what we have found is that where you need a number of layers of carbon, like say, to build up your structural strength, and your 4 or 5 or 8 or more layers or whatever, we ended up having less layers of basalt to have better impact than that number of layers of carbon. And so you ended up being equal or less in weight to the carbon.
Thank you.
Do you ever make high voltage capacitors with this material?
Well, you certainly could. ABB has done some with it recently. ABB, they do a lot of that kind of work. And like I said, it is a 10 times better electrical insulator than and fiberglass is a good insulator, but basalt is actually an order of magnitude better.
Thank you, sir.
You're welcome.
I have to put you in touch with the people at Florida State University, the magnetic lab might have an interest as well. They presented last week.
We did all of our ICC testing for our rebar at the University of Miami. But yeah, we'd love to do that.
What kind of applications? So for the audience here, I think it's mostly DoD. Bill is a commercial company, but there's application to aerospace construction. We had talked about firefighting, insulation, the ballistics.
For sure. When somebody mentioned when they're doing 3D printing, and was that Chris?
That was Bill.
Bill. And are you putting like a foam core in that 3D print, in that matrix, or are you leaving it hollow?
We're leaving it hollow. So it's for manufacturing simplicity, it's an all Inconel vehicle, tanks, structure of the vehicle, engines, all Inca. It's maybe not optimum, but it works.
Yeah, well, we could reduce the thickness of your Inconel. Actually, we just did a study with a new geopolymer solution that bonds to Inconel and actually has 100% gamma containment. And the other versions of radiation are like 50% now, but a little thicker amount of it can actually reduce that by 100 as well. But the high temperature geopolymer, which is basically it's a cement ceramic that is Portland based. It's a luminosilicates and metakaolin clay. But what she found was it bonded to the inconel at 12 megapascals, and say super glue is 1. And when you take it to high temperature, it went up to 20 megapascals, which is stronger than any known glue right now on the planet. And we're reinforcing that geopolymer with basalt fiber fabrics as well.
Could be a good insulator for our cryo tank.
Oh yeah. Mm-hmm. Yeah, and the cryo tanks also, like I said, with the aerogel, I believe we could, and we have paint coatings that have the aerogel in them for high temperature insulations. We've got one that my guy in Montana does that is a paint coating. It's rather thick, but I have a crater with U.S. Navy and that I got from Naval Underwater Warfare Center up in Newport, Rhode Island, where I live. And we held at a battery company that makes 90% of the U.S. military batteries. We painted carbon basalt and fiberglass, went like an 1/8 of an inch thick on 1/4 inch composite panels. And we held a 2,000 degree blowtorch on it 2 inches away for 10 minutes and never burned through. And the thermal probe on the backside, the most it got was 165 degrees Fahrenheit.
Yeah, just this is Eugene again. Just to chime in, I kind of I pushed these both Brian and Nick here to present today, and that's one of the reasons why we're having this many challenges, because they didn't have the time that they needed to present. But this was more to be an introductory presentation.
Right.
Just reading on the back of Nick's card, the features and benefits of basalt. He talks stronger than fiberglass and tensile strength, non-respirable, inert, and safe to work with. 18% better elastic modulus, UV immune, non-conductive, will not corrode, will not harbor bacterial or microbial growth. Better impact resistance, doesn't shatter like carbon fiber. 10 times better electrical insulator than fiberglass. And it goes on and on and on. There's another dozen or so of these. And there's going to be a series of presentations following this one presentation. These are going to focus on the different industries. One of them will be construction. One of them will be energy. One of them will be DOD applications, and that'll mostly be for ballistic applications. There'll be talk about aerodynamic or aerospace. So Navy, there's so many different applications that we can't cover it all in one. But please keep a lookout. They're going to be coming back several times over the next several months, so that we can spend the time to address things like applications in medicine for creating structure for bone and calcium growth, and same thing with construction. So
Yeah. Mm-hmm.
So those will be coming, and everybody will have a better opportunity to get more in depth in those different applications. We talked about firefighting, heat, and just having to divide up how best to cover these.
Great, thanks. Yeah. And Eugene, if anybody wants to send you an email now to ask for that slide deck that I have, I think if I send a direct link from my presentation, they
can just drop it.
Open it.
You can just drop it in that.
Yeah, and what I can also do is
like.
I can convert it to a PowerPoint, since it's a proprietary thing on my Mac right now. But I think I can convert that and give it to you as a PowerPoint.
Yeah, that'd be perfect. Or even a PDF.
Sorry,
it's fine.
That'd be good too. Yeah, sorry, I've been traveling, so it's been difficult.
No, and like I said, I mean, I pushed hard for this because there were a lot of people that I wanted to introduce this to and get to talk about this, so that we can schedule to follow on detailed conversations.
Absolutely. And the previous biosolidar discussion you just had, is there any way I can go back and do that?
Yeah, absolutely. That's all going to be on the YouTube channel.
Okay.
These recordings will be processed. I get them sometime Friday, Saturday, or Sunday, so it'll definitely be up on Monday. And then also, if you go to technologyideationllc.com, there is a link at the top called File Repo. That'll take you to the file repository, and that's where the presentations and the summaries and the videos are located there too, because you can't download them from YouTube. And that's something a lot of the federal people can't sit and watch one at work.
Right.
So they have to download it and watch it later.
Yeah.
But Brian, you wanted to say something?
Yeah, I just wanted to encourage anyone on this call, when you go back to work, ask your friends and colleagues there if they have ever heard of Basalt. Almost guaranteed nobody will have a clue what you're talking about. And I see that as an absolute shame, because it is such an amazing material. The cost to produce it is low, and it achieves so much more than anything else is. But start a conversation with your workmates. I think that'd be interesting.
Thank you.
So,
Well, I also think this points out the value of these conversations, which is, to discover the unknown, quote unquote, that the community just is completely unaware of.
thank you.
Right.
So Anakin,
Yeah.
you asked a question in the chat. Can you elaborate on that? What application you were looking at?
Yes.
Hi. Yeah. So I work extensively in the bioprocessing area and always look for opportunities to value add to various process streams. So I was curious, although it's not relevant to the Basalt product that was discussed, I wanted to get a take from Nick about potential application of cell biomass in any of these cool polymeric applications.
Yes. And although I'm not completely familiar with cell biomass, but I know cellulosic waste tree material. Is that what you're talking about? Like basically from wood fiber turned into cellulosic reinforcement or other product. That's what you mean, right? From wood waste.
Yeah, that's one of them. Yes.
Yeah. But absolutely, because a lot of natural fibers or cellulose fibers have a certain amount of structural capacity, but I think the basalt, being all natural and all rock, is a great addition to any of those to give it more structural capacity while still being completely all natural and renewable, sustainable arena, rather than to having at the end of life having to have some chemicals to extract one from another. Or anything of that nature. It's inert and safe, and it's all rock. It will bring properties, high temperatures or expansion properties or just basic mechanical strength to pretty much everything of that nature.
Okay, cool, thanks. Is there a way we can connect offline to see if we can test out a few materials?
My email is nick@basalt.email.
Yeah, if you just write me and
Yeah,
get we're
right there,
connected
Eugene.
now, I
Yeah.
can put you in touch.
Yeah.
It's the first conversations I
Thank
always
you.
like to participate in.
Yeah.
Sounds great. Thank you.
You're welcome. And Eugene will forward everything.
Right. And then some of the other things we talked about too, Nick, were being able to weave metallic fibers into this and reduce signatures, whether they be thermal, IR, or possibly even RF.
Yeah. Yeah. Commingling of fibers has been done, and it's certainly capable. Like I said, we make every type of weight and weave of rovings or yarns that you would want to do that with.
So what does that do to does it degrade the fabric at all? Is there like if you were to put in 10%, let's say wire, whether it be aluminum, copper, would that degrade the properties by 10% or greater, or how does that work?
I don't know. That would be worth testing. There's so many variables and things I hate to say yes or no about it, anything unless I've done it myself, and I haven't.
Yeah, so there you go. So Department of Energy labs, Air Force research, and Naval and Army research labs. Feel free to reach out. That might be an interesting pursuit.
Absolutely. Yeah. I don't think there's been enough of that done, actually, examining commingled fibers and woven fabrics.
Yeah, I did a lot of work go ahead.
Sorry, have you looked at the RF reflectivity, what the signature of this material is? Over.
Well, it's RF immune. That's why the Russians kept it a secret for decades. It's basically does not refract RF signal.
Interesting. Thank you.
Mm-hmm.
Yeah, because I worked in signatures. That was one of the fields that I worked in, and I worked in infrared, electro-optical, and RCS. So I can definitely see applications there.
Mm-hmm. I know there's a company wrapping a fiber optic cable with it now.
Well, I guess that would work kind of like Kevlar. I used to do. I know there's Kevlar wrapped fiber optics that you can run a deuce and a half over with bulletproof tires and not damage it. And those are usually long, multi-kilometer runs on the ground of fiber.
Right. Yeah. And I think Basalt can be actually a better animal, and it doesn't. It can handle much higher and or lower extreme temperatures than Kevlar's can't, and it's probably 4 times less expensive, at least.
So what about? So it's immune to RF, so it wouldn't work for shielding. What about rodent protection?
Well, what rodent?
Yeah. So a lot of cables are damaged because rodents chew them in the ducts.
Yeah. Well, it might be that you have some kind of a chemistry that you could apply to it to help in that, but it is rock, so I would imagine that they would get kind of wear their teeth out pretty quick if they're chewing through rock.
And they chew through the wire.
Right. Yeah.
But I was curious.
Yeah. There are some companies that said that they came up with some chemistry for that, but I don't know what that is. I know they use Tabasco and things like that.
Right. Yeah, exactly. Hot peppers, and I did some work in the Arctic Circle, and we were running hundreds of thousands of kilometers of cable, and that was one of the issues, was for it to be rodent proof.
Yeah. And to go back onto the aerogel fabrics, and as far as stopping thermal runaway or whatever, but for those extreme cold temperature applications, I would hope somebody could pay attention to the fact that, well, like I said, when you build a refrigeration unit, and that could be a reefer truck or any kind of a refrigeration or whatever, by almost doubling your storage capacity and reducing the amount of energy that it takes you to keep that temperature, right? Because, there's a lot of either propane or electricity or whatever that it takes to keep your refrigeration cold. So with the aerogel fabric, you don't need that 3 inches of foam or more that they're putting in a refrigeration unit. Right now you're down to 2 millimeters, so you're exponentially increasing your storage capacity while reducing the amount of energy it takes to keep that refrigeration at temperature.
And now I guess I only know it by R value. I don't know if there's a different value for
it's a K value in milliwatts. Okay. It's like ours is like down 15 to 20 milliwatts, and others are 40, 50 or more.
Now, if you add layers or thickness, is that a linear transition or?
Up to a point. I think there's a point of no return, but you can put multiple layers and get a better K value. Having any airspace obviously in between is always, good.
And have you done anything in the micrometeor realm of spacecraft?
I haven't. But the fabric that we start with, though, is used by NASA. That's what I would imagine they have.
I know definitely a lot of interesting possibilities, and looking forward to the series of presentations that we have going or have planned, and getting more and more people involved in this. I was first exposed to basalt fibers when I was working on attritable systems at NAVC, specifically, trying to use this to put around a hull to help make it anti-ballistic.
Oh. You can
So I
certainly
can
do
see
that.
applications. Yeah, contested logistics for we've got. I mean, I know Brian chimed in with Hypersub about applications of the fabric to their product. And it's just amazing the number of applications.
And like I said, we've been doing some work in hydrogen storage, and we have sleeve. It's almost like that Chinese finger tube stuff that gets bigger and smaller as you pull it and conforms to round vessels. And it's working fantastic. And like I said, that study that showed the basalt being better than carbon for super low critical below Kevlar, what is it? Kelvin. I'm sorry. It's like hundreds of degrees below zero, and the basalt was outshining carbon in not only tensile but flexural and hoop strength.
All right, so one more opportunity for questions before we wrap this up. Anybody?
Thank you all.
All right, thank you, Nick. Thank you, Brian.
Thank you.
And Brian, did you talk to Tom Painter? Were you on that call with FSU, Florida State, and the Mag Lab?
I'd have to look into that. I'm gonna say yes, but not for sure.
Okay. All right.
Was he the magnet guy?
Yeah, he's a magnet guy.
Oh, I had a great conversation with him, and he doesn't know anything about basalt. He's super excited.
Okay, good. Glad to hear it. That's what we're here for. Just like Bill said. I mean, bring this this kind of technology, these kind of developments out to a broad audience, and then share that. The beauty of this one is that there'll be multiple opportunities for people to come back and hear more about it and look at the specific applications. So again, thank you all for attending. Thank the presenters for presenting, and hope to see you here next week.
Thanks, Eugene.
Yep. Take care.
See ya.